In this video I'm going to be demonstrating how to set up the BV Analyser. So if you've installed the software yourself, you would have been sent a link, and when you download the file from the link and run it, it will run like a standard install file, and at the end of that process you should find an icon on your desktop called BV Analyser. So if you double click on that, first time you run this, it will put up a request for license details. So there are two ways of licensing the program. If the system is going to have internet access, then the preferred way is the online licensing, and you will have been sent an email address and also a serial number or license code like this. If the system that you're going to be running the BVA on doesn't have internet access, there is an option for offline activation, which is a slightly different process. But we'll assume that the system that you're installing on has internet access, and you'll have received the details of the email address and activation code for the license. All you then have to do is click on Activate, and it will then communicate with the license server and approve that there is a license available. While we're on that subject, if you want to deactivate a license to transfer the program to another computer, then you can simply go to Help at the top here and check License. You can then deactivate this license, and then you'll be able to reactivate with the same details on another computer. But obviously it will only allow you to run this license key on one computer at a time. So the first time that you run the BV Analyser, there are a few settings that you need to check, and you need to calibrate the system. So if you select Settings and then select the Settings button here, it will put up this window. You can change things like you can put a logo on your reports, and this shows the location of a logo. You can then scale the logo depending on its size. The splash picture is the picture that comes up on the patient screen. By default that's showing a tulip field, but if you've got another image you'd like to put up there, you can browse to that and select it. The program will also generate PDFs of these charts, and this is the default location for storing those PDFs. I'll say a bit more about that in a moment. The play instructions is an option whereby it speaks instructions throughout the test if you've got sound on your computer. The database tab shows where the database is stored. The program uses an SQLite database, which is nice and fast and also has the advantage of being a single file. So if you need to transfer the database to another computer, it's literally a case of copying over this file to your new computer, then reconnecting it on your new computer. A lot of hospitals in particular create a shared drive. It needs to be a mapped shared drive rather than just a network drive, so you need to map it so that it's got a letter associated with it, like Z or Y, and then you can store the database on the shared drive, and then more than one program can get access to that database, so the data can be shared between two or more systems. This is the program directory. Probably best to leave that where it is. By default the program is installed in the root directory in a subdirectory called Binocular Vision Analyzer 2020. The program also has a backup facility. You can see the button here. This will simply copy over the database file to your backup location. It obviously makes sense for this to be either on an external drive or USB stick, or on a shared drive. It doesn't make much sense to have your backup directory on the same computer, just in case that you get a problem with that computer. So those are the files involved. The program will run on a single screen, but it works much better on two screens. and ideally the second screen should be a large television screen if you want to be able to go out to plus or minus 30 degrees as is required for a full HES screen. So you can see on this computer I've got two screens attached, and the admin screen is the one that the practitioner will be looking at, and the second screen, the test screen, is the one the patient will be looking at. So you need to set this up so that the red rectangle is on the correct screen, the green rectangle is on the correct screen. You could just type in the left, top and width and height dimensions of each screen, but the quicker way of doing it is simply just to click on screen 1 or 2, and it will then automatically add the correct values to these boxes here. So once you've done that, the test screen should appear on the patient screen, which is ideally a large television screen, and the admin screen will be showing what you're now looking at. The other thing that you do need to do before you actually do the test is to calibrate the colors. So when you select the colors tab, you'll see on the patient screen there's a red and a blue circle. Now it's really important that the colors on the screen are well matched to the red-green goggles that you're using. And what you're trying to achieve is that when you look through the red filter, you can see the red circle nice and clearly, but the blue circle completely disappears. And likewise, when you look through the green filter, the red circle should disappear completely and the blue circle should be reasonably clear. But because different screens reproduce colors in slightly different ways, then you may need to tweak the colors a little bit to get a perfect match. And to do that, if you want to change the color of the red circle, you can do so. You've got either an RGB model or a hue saturation brightness model, whatever you prefer, and you can change the colors slightly here, and you can change the saturation, and you can also change the brightness. So it really is a matter of trial and error while you're looking at the TV screen, looking through the red and green filters, trying to find a red that is reasonably bright when you look through the red filter and yet makes the blue completely disappear. And then you do exactly the same for the blue circle. On some occasions, in order to get a really good dissociation, it's necessary also to play around with the colors on the television settings itself. But it's usually possible to get a pretty good separation of the colors. It's really important that that separation is good, otherwise the patient will see a shadow on the screen, and that gives them an additional cue, and that can affect results. So that's colors. There are a few settings here for the HES. These are the default configuration of the HES test. So by default it's set to a circle and a quick test. You can also have a full test, 25 points. The flanks are, because the television screen is wider than it is high, we can go out further horizontally than vertically, and we call those extra 8 points the flanks. So you can add those if you like. This version of the BVA has a number of analyses available for the HES chart. There's the Elwood analysis, the Ferruta analysis, and an area analysis, and this just shows which of those is selected by default. The reverse charts on the page will do exactly what it says. It will place the field of the right eye on the left and vice versa, the field of the left eye, which some people seem to prefer. There are also a few settings for the field of binocular single vision and the uniocular field of fixation. So this refers to the number of pixels that the stimulus moves back after recording. So as the stimulus moves out along a radial, when you click on record, it will then move in by this number of pixels along the next radial before moving out again. So you can select that, or you can always return right to the center of the screen. Allow multiple diplopia points along axis. This is an option that you can enable, which allows you to plot out islands of single vision and diplopia. It allows you to, by default, select areas where it might go from double vision to single to double vision to single. Otherwise, it assumes that you've got single vision in the central field and get double vision as you move out. And you can either select to do measurements every 15 degrees or 30 degrees or 45 degrees, but you'll see when you do the field of binocular single vision test, you can actually skip any of these if you don't want to test them. For the uniocular field of fixation, you can choose by default to test the cardinal directions only. That is, it will move the stimulus along the field of action of the 6 extraocular muscles. And the show analysis, it will by default show the total area in square degrees of the field of binocular single vision after you've done the test. All of these things can be turned on manually on a post hoc basis when you've done the test. These are just the default settings. So those are all the settings. It's really important that you get those set up properly before you start doing any testing. The other thing that you do need to set up is the calibration screen. So if you click on Calibrate, you will then see on your test screen a Hess type grid, and on that you can enter the width of the screen. That's the total width of the screen in millimeters, total visible area of the screen, and also the height of the screen, and also you type in the viewing distance. So ideally you want the patient with their head on a headrest so they can't move the head, and then you measure from the eyes to the center of the screen, and you make a note of that in centimeters. You can change that, and as you change any of those settings, you'll see that the grid that is displayed will change to reflect that. So the bigger the screen and the closer the patient, the larger the area of the field that you can cover. But obviously there is a limit on how close the patient can be placed. We generally recommend that you don't come much closer than 35 centimeters, otherwise it puts too much demand on accommodation and convergence. So 35 to 40 centimeters is normally what's required. So once you've actually measured the width and the height of that screen and entered the viewing distance, you click on Save, and that result will be saved, and then your charts will be properly calibrated. There's a couple of other things that you will need to possibly add. This is the name of the clinic, and you can have more than one clinic set up. So at the moment, by default, it's Thompson Software. You'll obviously want to change that. You don't necessarily need to add a name, address, and the other details. And that comes into play when you actually add a patient. So when you add a patient here, all the organizations that you've added will be shown at the top, so you can assign a patient to a particular clinic or organization. While we're on this screen, you need to enter the patient's gender and their title, first name, surname, date of birth, and ideally a reference number. Again, the other fields are optional. And when you add a patient, their name will be added to the list here at the top. You can edit any of these things, so you can edit the patient details at any stage. You can edit the organization details. You will need to add an orthoptist, so that when you do a test, the names of all the orthoptists will be contained in the list at the top there. So every time you do a test, it needs to be assigned to the orthoptist or the screener who's done the test. So that is about it in terms of the initial setup. In another report, in another video, we'll be covering further details about how to actually run the test.